Come back. Section 10.3 Polar Coordinates. First, let's recall the rectangular coordinates, also called the Cartesian coordinates. Point AB is so named because its x coordinate is A and y coordinate is B. So what is x coordinate? It is the distance from origin when you drop the point AB down onto the x-axis. What is y coordinate? It's the distance from origin when the point AB is dropped onto the y-axis. All right. So this forms a rectangle, these 3 points. The y coordinate 0b, the x coordinate point A0 and the point itself AB along with origin 0, 0. Now we'll introduce the notion of polar coordinates. Choose a point on the plane called the pole. Pole is the origin. It's labeled O, so that's your pole. A ray starting at O and moving right, as in overlapping the x-axis, is called the polar axis. Polar axis is a ray, starts from your origin, moves right. Now, given any point on the coordinate, on the plane, let R represents the distance from O to P and theta represent the angle in radians measured counterclockwise from the polar axis to OP. So from the polar axis you move towards P. So this direction is called counterclockwise. Your angle is between 0 to 2 pi. Notice 0 is included, 2 pi is not included. So the pair R theta represents the polar coordinates of P. What are the polar coordinates of origin? It is 0, 0 because distance from 0 is 0 and the angle with the polar axis is 0. So notice the second coordinate represents angle in radians measured counterclockwise from the polar axis. From the general definition of trigonometric functions, what do you know? X coordinate is r cosine theta, y coordinate is r sine theta. For any point, r theta are coordinates in polar coordinates. But what about rectangular coordinates? X is r cosine theta, y is r sine theta. R, the distance from 0, 0 is x squared plus y squared. Tan theta is y over x. Suppose, here is example. Suppose P is the point 3, 7 pi by 6, which are the polar coordinates. What does 3 represent? 3 is the distance of point P from origin. 7 pi over 6 represents the angle in radians measured counterclockwise from the polar axis. X coordinate then is 3, that's the r, cosine theta, 7 pi by 6. Cosine of 7 pi by 6 is negative root 3 over 2. So there is a 3. In all, you get negative 3 root 3 by 2. What is y coordinate? 3 sine 7 pi by 6. Sine 7 pi by 6 is negative half. So this gives you y coordinate to be negative 3 halves. So the Cartesian coordinates of P are negative 3 root 3 by 2, comma, negative 3 by 2. Now suppose you are given Cartesian coordinates of a point. Find the polar coordinates. Well, negative 2, 3 are the Cartesian coordinates. So what is r squared? It's x squared plus y squared. Negative 2 squared plus 3 squared. 4 plus 9, 13. That is r squared. So r is square root 13. Tan of theta is y over x. That's negative 3 over 2. So theta is arctan of negative 3 over 2. Keep in mind, negative 2, 3 is the second coordinate. Okay, so second coordinate. So you have to keep in track the angle and so on. So regardless, arctan negative 3 over 2 will give you a negative angle, but you need to be on the you need to add pi over 2 to get the actual angle. Okay, so mind you, the complete, you don't want a negative angle. Your angle must be between 0 and 2 pi. So you need to adjust this accordingly based on where your point is. All right. Let's sketch the curve r equals 3. R equals 3 means square root x squared plus y squared is 3. Take squares of both sides, x squared plus y squared is 9. Well, this is equation of circle centered at origin, radius 3. That's what r equals 3 means. Radius is 3. So that's your circle. So to sketch the curve r equals any constant, positive constant, you are going to get a circle. Now suppose theta is a constant. Theta is pi over 4. So angle theta is pi over 4. So any point on this ray has angle theta pi over 4. So notice here, if I'm allowed only non-negative radii, then I only have this ray. But if my radial distance is allowed to be negative or positive, then I have an entire line. So theta equals a fixed angle gives you either a ray, depending on whether you have a constraint or not, or a line. Okay. In general, how do you sketch curve? Say, for example, r equals 3 cosine theta. Well, what you do in this case is, make sure you build a table for varying theta values. So these are the standard trigonometric angles that you would use standard. Theta is 0 or pi over 6, pi over 4, pi over 3. I hope you recognize these. All the way to pi over 2. So these come from the first quadrant. Now second quadrant angles, 2 pi by 3, 3 pi by 4, 5 pi by 6 until pi. Then third quadrant angles, 7 pi by 6, 5 pi by 4, 4 pi by 3, 3 pi by 2, and the last quadrant, fourth quadrant, 5 pi by 3, 9 pi by 4, 11 pi by 6. For each of these theta values, use your original given equation r equals 3 cosine theta and find the exact values of r. Once you build the table for these precise values of theta, now you are ready to label the polar coordinates, points in polar coordinates, r, theta. So r first, then theta. Okay, so you get a bunch of points. These points help you graph. You have to graph them carefully. So notice pi by 6, pi by 4, pi by 3. Okay, why am I all here? Notice, if you look at the points, 3, 0. What does this mean? Distance from 0 is 3, angle 0. So that gives me this point. Next point, 3 square root 3 over 2, angle pi over 6. So when angle is pi over 6, this distance is 3 square root 3 over 2. Likewise, angle pi over 4, 3 square root 2 over 2. Angle pi over 3, 3 over 2, and angle pi over 3. When angle is pi over 2, 3 times 0. So that's why you are here. What happens to these angles, right? when angle gives you the second quadrant. When angle is here on the second quadrant, look at the R. They are all negative. So when you are here, angle is here, your R value takes you back, and that gets you these points. Okay, until angle pi, which gives you negative 3R, landing you back to this point. So basically, from here to here was nothing but angle 0 to pi. Okay, so 0 to pi brought you here. What happens at after pi? After pi, notice we still have negative values until 3 pi over 2. Okay, so that's the third quadrant. So for these angles, again, R values are negative, so I land back here. So actually, I'm going over the circle twice by the time I come to my last point. Okay, so now when I'm on the fourth quadrant, my R distances are positive, and that's okay. So I'm on the fourth quadrant. These points are what I get. So to repeat, angle 0, I'm here. Angle pi over 6, I'm here. Pi over 4 here. Pi over 3 here. Pi over 2 here. Right? And then 7, then here. 2 pi over 3, I'm here. 3 pi over 4, I'm here. 5 pi by 6, I'm here. Pi, I am here. 7 pi by 6, I'm here. 5 pi by 4, I'm here. 4 pi by 3, I'm here. 3 pi by 2, I'm here. Then I'm positive values. So angle 7 pi by, 5 pi by 3, then 7 pi by 4, then 11 pi by 6, and then 2 pi by, basically 2 pi. So as I go through my entire 0 to 2 pi angle, I traverse through this circle twice. Here is another way of seeing the same curve. R equals 3 cosine theta. Let's look at x. X is r cosine theta. That means r itself is 3 cosine theta, so 3 cosine squared theta. Y is r sine theta, so y is 3 sine theta cosine theta. Now we know r squared is x squared plus y squared. So squaring this gives you 9 cosine squared equals x squared plus y squared. But 9 cosine squared, right, is 3 times 3 cosine squared. So that is 3x. So 3x is x squared plus y squared. Subtracting the 3x, you get x squared minus 3x plus y squared is 0. Complete this as a square. Take the negative 3, divide by 2, square it. Whatever you add here, you must add to the right hand side and obtain this. So now look at this. X minus 3 halves squared plus y squared equals 3 halves squared. This is nothing but a circle centered at 3 halves, 0, radius 3 halves. And that's exactly what happened. Centered at 3 halves, 0, radius 3 halves. All right, we'll continue with example 6 in our next video.